bucka. Ha. You know the deal.
The next thing we're going to explore is something called Pythagorean Theorem. And the first question you're probably going to ask yourself is, what is the Pythagorean Theorem? And simply put, the Pythagorean Theorem is a relationship between the lengths of the sides of right-angle triangles. So an important thing to note here is this equation, this theorem that we're going to be discussing, only works for a certain type of triangle, and that's a right-angle triangle, which means a triangle that has a 90-degree angle. So we're going to talk a little bit about right-angle triangles and some terminology involved in right-angle triangles first. So here we have a picture of a right-angle triangle, and it is a right-angle triangle because this little square here indicates that we have a right angle. And a right angle is a 90-degree angle. So on a right angle triangle, we have the two sides that are attached to the right angle, that are touching the right angle. And these are often referred to as the legs of the right angle triangle. And then our third side, which is directly across from the right angle, so not touching the right angle, but the right angle kind of opens up towards that side. That side is called our hypotenuse. And regardless of what the right angle triangle looks like, the hypotenuse is always the longest side of the right angle triangle. So the side that's directly across from the 90-degree angle is always the longest side of the right angle triangle. So here we have three examples of right angle triangles with the given lengths. And when you look at these lengths, once again you can see that the hypotenuse, the side across from the right angle triangle, is the longest side. So for our first right angle triangle, the hypotenuse is 5 centimeters directly across from the right angle triangle. For our second right angle triangle, the hypotenuse is 13 centimeters. And for the third triangle, the hypotenuse is 25 centimeters. These are all right angle triangles that would have these measurements on them. And when you look at these measurements, it's not very clear what the relationship, there doesn't seem to be any relationship between the lengths of the sides. And that's because the relationship is not actually connected to the lengths of the sides. But if we attach a square to each one of these sides, we start to see what the relationship is. So here you can see all I've really done here is just attach squares to each one of the sides of all of the right angle triangles. And if we calculate the area of each one of those squares, well, to calculate the area of a square, it's length times width. So if we start with this square, for example, the length is 3 centimeters, so the width is 3 centimeters, which means the area is 9 centimeters squared. Just to save a little bit of time and room, I'm just going to put the digit and not the unit. So there's the area of that square. The area of our square down here is 16 centimeters squared. And the area of the square attached to the hypotenuse is 25 centimeters squared. If we take a look at our right angle triangle over here, again, if I calculate the area of each one of the squares attached to those sides, this smaller square here is 25 centimeters squared. The area of the square attached to this side is 144 centimeters squared. And the area of the square attached to the biggest side there is 169 centimeters squared. And we're just getting those areas by multiplying the length times the width. And since they're squares, the length and the width is the same. And finally, on the last one here, the length of the smallest square is 49 centimeters squared. the area of this much larger square, but not the largest square, is 576 centimeters squared. And the area of the biggest square here is 625 centimeters squared. And the biggest area is always attached to the biggest square, which is attached to the biggest side. And the biggest side, as we can see again, is always the hypotenuse. Well, now if we start to look at these numbers here, the areas of the square, you probably start to see that there is a pattern with the areas, and that is when you add the two smaller areas, it always equals the bigger area. So in other words, with the first right angle triangle that we have there, if we add 9 plus 16, so the area of those two smaller squares, 9 plus 16 is 25. With the next right angle triangle, when we add the areas of the squares attached to the side, 25 plus 144 is 169. And with the last one, 49, the area of the square attached to the side that's 7 centimeters long, plus 576 is 625. So what we can see here is that with Pythagorean theorem, it doesn't so much have to do with the lengths of the sides, but it's more about the areas of the squares attached to the sides. And what we can see here is that the area of the squares attached to the two smaller sides, when added together, equal the area of the square attached to the biggest side, or the hypotenuse. And that's really what Pythagorean's theorem is. So, to sum up Pythagorean theorem, again, Pythagorean's theorem only works on right angle triangles. And on any right angle triangle, the areas of the squares attached to the two smaller sides, also called the legs, when we add up those two areas, they add up to be the area of the square attached to the biggest side, or the hypotenuse. So let's explore a couple of examples of this. So suppose we have a right angle triangle where we're given the lengths of the legs. So one leg is 6 centimeters and the other leg is 8 centimeters. And we don't know how long the hypotenuse is. Well, as we've just seen, the relationship on Pythagorean's theorem has to do with the areas of the squares attached to the side. Let's again attach squares to each one of these sides. So when we do that, we can go ahead and calculate the area of the square attached to one of the legs here. The area is 36 centimeters squared. We get that by multiplying 6 times 6. That's how we get the area of a square. And the area of the square attached to this side is 64 centimeters squared. Well, as discussed, to get the area of this square, the biggest square, we add the areas of the two smaller squares. So the area of this square is 100 centimeters squared. Now that's all good and fine, but what we're being asked for here is the length of the side. So we know the area of the square, and as discussed in the previous video on squares and square roots, if we're given the area of a square, which we're given here, and we want to know the length of the side, well, what we have to do to that is square root it. That's what square root means. Square root means we have the area of a square and we want to know the length of the side. And the square root of 100 is 10. So the length of this unknown side is 10 centimeters. So let's look at another example. Here we have a right angle triangle, and this time we're given one of the legs and what the hypotenuse is, and we have to calculate what the length of the other leg is. Well, I'm not even going to bother drawing the squares here, but if I were to draw the squares, if we're going to calculate the area of each of the squares here, the area of the square attached to this side would be 64 centimeters squared. The area of the square attached to this side would be 121 centimeters squared. Now, as we talked about in Pythagorean's theorem, we add the areas of the two smaller squares together to equal the area of the biggest square. And the biggest square is always going to be attached to the hypotenuse. So that means that 64 plus the area of the square attached to this side is 121. So to calculate the area of the square attached to this side, we have to subtract 121 minus 64. And that gives us 57. Now again, that's all good and fine. Now we know the area of the square that's attached to the unknown side here, but we need to actually know the length of that square. So if we know the area of a square and we want to calculate the length, we have to do the square root. And 57 is not a perfect square, which means we're either going to have to come up with an estimate or use a calculator to calculate the square root of 57. I'm going to go ahead and use my calculator for this one. And the square root of 57 is about 7.5 when rounded to the nearest tenth, which means the length of this side is 7.5 centimeters. When students are first learning about Pythagorean's theorem, the most common mistake students make is forgetting that the hypotenuse always has to be the longest side, which means the area of the square attached to the hypotenuse always has to be the biggest area. So if you're given the hypotenuse and another side, you're always going to subtract the areas to get the unknown area. Alright, so to finish off our lesson on Pythagorean Theorem, I'm going to ask you to answer a few questions here. So for question number 1, you're asked to use Pythagorean Theorem to calculate each unknown side on those three triangles there. So a first triangle, you're given the two legs. One's 3 centimeters, one's 4 centimeters. So again, you're going to calculate the area of the squares attached to those two sides, add them together to get the area of the square attached to the hypotenuse, and then find the length of the side, so find the square root of that area. With the second triangle here, you're given the hypotenuse and you're given one of the legs. So remember, the area of the square attached to the hypotenuse is always the biggest square. So you're going to have to think about what you do with the two areas there to get the area of the square attached to this side. Now with the last one, I've only given the hypotenuse, but I've also given the fact that these two lengths are the same. So this one's a little bit of a tricky one. One thing I might suggest you do is use a little bit of algebra here. So you can call this side x, and if that side's called x, this side is also called x. And again, calculate the areas of the squares attached to the sides, and write an equation that shows the relationship and try to isolate x. With question number 2, you're given a word problem here. So you have a ladder that's 13 feet long. It's leaning against a building, and from the bottom of the building to where the ladder is, it's 12 feet up. And the question is, how far is the bottom of the ladder from the bottom of the building? One thing I might suggest you do for question number 2 is draw a picture. And once you draw a picture, you'll probably see how you use Pythagorean's theorem to answer that question. If you're able to answer those questions, congratulations, you now have a firm understanding of Pythagorean's theorem.